we are having nearly 6 theorems to study in the second module, which depends upon the mesh and node analysis. Hope you can see the screen. So first we'll go on with superposition. We have nearly superposition theorem, reciprocity theorem, Milmans theorem, next Thevenin's and Norton's, and the last one is maximum power transfer. So all these theorems are your second module portion, and all that depends upon the basics of the first module. So becoming perfect with first module is required, where we'll be using all the theorems has their own method of solving, so you have to follow them. We'll go on with the first network here, or the first theorem which we had studied about superposition theorem. So first I'll tell what is the superposition theorem. In superposition theorem, or the method that should be followed is, in a network, if it may contain any number of independent sources. Okay, there may be any number of independent sources. The procedure is you have to take one source at a time. So when you take current source at a time, and if there are any voltage sources, they should be shorted. And if you take voltage source first, then the current source should be open circuited. Okay, and you should not touch this dependent source. Dependent source should be kept as it is. That is one important thing of superposition theorem. So in the given network, we have a current source 2, and we have 3 volts voltage source, and we have a dependent source. See the symbol of the dependent source here. It is what? It is current dependent current source. Fine. It is depending upon the current only. Depending upon which current? The current in the 5 ohm resistor. It is depending upon the current in the 5 ohm resistor. So one source at a time you have to take. So first tell what they have told. You have to determine the current Ix. First consider 2 amps. When you consider 2 amps, the 3 volts should be shorted. Okay, you have to short this 3 volts and just write the loop equations. And since this is a current source, so the output current, or there is a current source in the border of the circuit. So whatever the current for Ix will be nothing but I3. Okay, and it is going against the direction. So I3 will be minus 4Ix. So we have two to three loops. And the last, the here also, I1 is 2 amps. We'll get the answer correctly and directly, because 2 amps also is at the border of the network. And this 4Ix also is at the border of the network. So in place of Ix, what you will write? You should write the current in the 5 ohm resistor. What is the current in the 5 ohm resistor? It has two currents. That is, if you take first loop as I1, second as I2, third as I3. Okay, so it consists of two currents now. Okay, you take this as I1. Okay, this as I1, and this current as I2, and this as I3. So we have two currents in 5 ohm resistor. First one is I2 minus I3. Okay, Ix is nothing but I2 minus I3. So instead of Ix, you can write I2 minus I3. Okay, so follow that method and solve this problem. And when we consider 3 volts, this completely 2 amps, completely this loop will be removed when we consider 3 volts. Okay, 2 amps is a current source. It should be open circuited. So you'll be left out with only 2 loops. Just take two currents, I1 and I2, and we have a border current source. So I2 4 Ix, and in place of Ix, you should write the assumed currents in these two loops. So try to solve this problem using superposition theorem. So you have to take one source at a time. You have to remember, and in superposition they always mention what you have to find. Here they have told you to find current. They may tell you to find voltage also. At what point they have told you to find, that should be done. And at last you have to combine and write the answer. That is, you have to write the current Ix because of both the sources. You have to write because of 2 amps and because of 3 volts. Put them together and write the answer. Next theorem is our reciprocity theorem. Reciprocity theorem is just the excitation and the response are interchanged. Fine. Here we have 8 volts as excitation and I is the response. Fine. First, as usually, find the current I. How you will find the current I? You can take 1, 2 and 3 loops. You can go with the mesh analysis. They take 3 loops. So the I is in between these two loops. So whatever the current you get in the two loops, that is, if this is I1, this is I2, this is I3. So I2 minus I3 will give you I. So that is the first method. Next, what you have to do, you have to interchange. Bring this current I here. Just you have to short this here. Okay, you have to short here. This will be I, and put the voltage source here. If at all it is not possible to know the polarity correctly, since the current can go in through 8 ohm also, it can go through 10 ohm also. Since the polarity is unable to identify, so what you do, you just keep one polarity, you assume one polarity and solve the problem. So if you get negative answer, just change the direction of the current. Okay, and if you get negative voltage also, just change the polarity. It means that the what we have assumed is just opposite to it. Fine. So voltage source should be kept here. You can keep plus and minus. Okay, plus can be kept at the downward direction, and the current should be put in the voltage place. Just the excitation and response have to be interchanged, and you have to take the ratio, that is V by I ratio. Okay, when you take the V by I ratio, then you will, if you get the same answer, then the reciprocity theorem is proved. That is one important thing in the reciprocity theorem. First, as usually, find I. Next, change the position of I and the voltage. Bring I here and voltage here. Okay, just change the position. Next, third one is the Milmans theorem. Find current I using Milmans theorem here. Milmans theorem, we have just a formula there where the many voltage sources are connected in parallel. Okay, when voltage sources are connected in parallel, you have to go with the formula, just to substitute here. Here one important thing is they have given a current source with parallel resistor. Okay, convert it into, do source transformation and convert it into voltage source. So V is equal to I into R. Just convert it into voltage source, and polarity is plus minus. Wherever the arrow is there, you have to put there plus, then minus, and put this 4 ohm resistor in series with the voltage source. Then you convert this into a single voltage source with series resistor. Just find out the current here. You can find out the current by using mesh analysis, or you can again do source transformation and find out the current I in 5 plus J5. Okay, they have given a impedance terminal here, or impedance component. So this is about the Milmans theorem. In Milmans theorem, we have the formula that should be taken. Okay, the voltage divided by its resistance or its impedance, whole divided by 1 by Z1 plus 1 by Z2 plus 1 by Z3. We have that formula. You have to take that formula for Milmans theorem. Next, this all the Thevenin's, Norton's, and this maximum power transfer will go in parallel. So here what they have given, determine the current through 1 ohm resistor. Okay, this is the current. You have to find the current in 1 ohm resistor using Norton's theorem they have mentioned. So which is the load terminal here? The load terminal is 1 ohm resistor. First, in Thevenin's or Norton's, you have to go with the load terminal. Okay, it is 1 ohm resistor. So for Norton's theorem, the load terminal should be shorted. After shorting the load terminal, you have to just find the current there. Okay, and to find the current, what you have to do? Take two loops, I1 and I2. Since we have a current source between two meshes, it becomes a super mesh. So just write the equation there. And what we have a dependent source also here, it is current dependent voltage source. Fine, it is depending upon the current I1. So I1 is nothing but the loop current I1 here. So you can just write I1 is equal to I1 only. Okay. And next what you have to do, since we have a dependent source here, we have to find out Z equivalent. Z equivalent is equal to open circuit voltage divided by short circuit current, that is ISC. That is the formula. So now short circuit current is nothing but Norton's current, which we will find out. Next you have to find out open circuit voltage. Open circuit voltage is just open this terminal. Okay, and you have to find out the voltage here. This is done in the class. You can see that it is just from here we have number is changed. Okay, we have 6 volts here. Since the terminal is opened, that means I1 is 0. If I1 is 0, this full dependent source is 0. Fine. So what will be the voltage here? Voltage is nothing but I into R, that is 5 into 1, it is 5. So here it is 6, it is 5. The difference is 6 minus 5, it is 1 volt. So the open circuit voltage will be 1, and find out the short circuit current, then you will get the Z equivalent. After getting the Z equivalent, you have to put Norton's equivalent circuit. So whenever we have a dependent source, you have to go with the formula like this. Okay. You have to find both the open circuit voltage and short circuit current, and then put the Nortons. If you don't have dependent source, then it is very simple. Looking from the load terminal, remove all the voltage sources. That means voltage source should be shorted and current source should be opened. And you have to check how the resistors are they are in series, are they in parallel. If we don't have dependent source, if we have dependent source, you have to go with this formula. Then after finding this open circuit voltage or short circuit current, then the maximum power transfer will be by using the formula. Maximum power transfer PM is equal to E naught square divided by 4RL. That is one. One more formula is IL square into RL, where IL represents the load current. Fine. We had seen some 3 cases for the maximum power transfer. So I have given some nearly 1, 2, 3, 4. In that one problem is solved, I feel. So nearly 3 problems are there. Try to solve them. If you are facing any problems, you can ask me. Thank you.